Awesome. Cool. So yeah, my name is Matt Baughman. I am a PhD student at U Chicago. I work largely on the serverless enabled cost aware space, specifically with heterogeneous environments. And these are kind of more the new heterogeneous environments of edge plus HPC plus cloud, where we're trying to get all of these different resources to work together and to work together well. So I think we're all pretty familiar with the current state of heterogeneity. Like I mentioned, there's HPC, cloud, edge, and they all have associated pros and cons. And specifically the pros and cons we're looking at are the costs that each one presents. So some of these have monetary costs, some are energy costs, some are resource capabilities. There are always limitations and benefits to each resource that we have to use. And of course, every application that we would have to run on these resources will run differently on each resource. So this is one of the reasons that serverless is so great, specifically FuncX, which is what we're using here for our system. And with serverless and specifically FuncX, enabling this model of compute where you can fire and forget a task and send it to any endpoint that is that you have control over, essentially. This is fantastic, but it also presents some new challenges, especially with a growing number of tasks, a growing number of endpoints. I think it was Eric Jonas who mentioned this yesterday, of managing just a vast number of endpoints and tasks, keeping those IDs straight, and then making selections out of these resources to spend specific tasks to as a problem. And so that's kind of the problem that we're hoping to fix, because we have all these different workloads and all these different resources, and we want to distribute them well, such that we are able to efficiently use all the resources that we have, whether it's the laptop that you're watching me on now, or some large distributed system. Let's see. There we go. So in order to do this, this automated FaaS cycle that we kind of developed falls along these three main principles of profiling, predicting, provisioning. So seeing how workloads run on different resources and trying to predict resource performance based on our previous runs, predicting the costs of that, and then making informed selections and actually getting the workload to the environment on which you're going to do the compute. So in order to solve this problem, we created the Delta Plus framework, which is really at its core just a wrapper around FuncX. So you can see just a code example in the top right, where the nomenclature is very, very similar to FuncX, and that's because all Delta Plus is really doing is abstracting away the layer of resource selection from the end user. So once you have a set of FuncX endpoints, you can register those with the Delta service. And then this Delta service, whenever you call a function through that, it essentially makes a selection out of your different endpoints based on past resource performance and past function performance on those different resources, and automatically sends that task then through FuncX, coordinating as well any data transfers that need to take place, and incorporating that information of data overhead into its selection of resources. So if you're trying to run analysis on a gross amount of data, there's a good chance that wherever that data is located is where the compute's going to happen, but Delta will make that decision for you. This is, like I said, built on top of FuncX, and is made to unify all the different resources you have, whether these are extremely low power edge devices or some of these very, very large systems. So moving on to specific elements of Delta Plus, costs and constraints are huge factors always when it comes to compute. How long does it take? How much does it cost? Those are very, very common questions. And we want to take that into account when we are firing off tasks. So as a end user, you can specify specific constraints in terms of cost, in terms of time, in terms of allocation SUs, and we allow for user definition of these different trade-offs. So For you as an end user, let's say you want your workload to run as quickly as possible, and you don't really care so much about the cost as long as it stays under your constraint, we can do that. We do this through a automated optimization process. So for whatever optimization criteria you leave unchecked, essentially, what Delta Plus does is it figures out this this trade-off space, and then it makes a selection of a resource based on the optimal criteria for, or the optimal condition for that workload to complete its execution under the constraints that you provided, and with respect to any other optimization criteria that you specified. And this is done simply by kind of creating these exclusionary spaces with respect to the different costs that you have identified. And then as you can see in this graph on the right, we're really just trying to find whatever the furthest green zone is, such that your workload would complete, and selecting resources along those cost trade-off criteria. So recently added to Delta is resource provisioning using FuncX, the AWS resource provider specifically. We're going to add more later. And so really this is just adding an auto scaling component to Delta Plus. Now, of course, with that, there's going to always be a trade-off, because there are overheads to spinning up new instances. Workloads definitely don't scale perfectly, and there are time costs then that we're fighting against, that maybe there are a lot of monetary costs and overheads, but if you can spin up 5 or 6 instances and your workload will complete in a couple minutes versus an hour, maybe that would be worth it. We developed this just that it would be plug and play with Delta, where all we're doing is exposing that provider as a new virtual endpoint, such that Delta can select it based on past performance, and then make the specific instance selection once it's decided that it is more cost effective to select a new cloud instance and all the overheads that come with that. So a couple of experimental results. We have a couple of setups. One, which is just demonstrating the multidimensional cost aspect, because originally Delta was developed just with respect to time and minimizing round trip time for tasks, but we added this multidimensional notion of cost. So we simulated this in several cases where we just have several different endpoints of different cost and performance levels, and really just sending sleep tasks to, and in this case, we did find originally that we're able to get within 10% of our optimal allocation balance within just a couple of these task batches to all the different endpoints. And then in this second graph in the bottom right, which I didn't write very much about, this was a simulation of our first demonstrator for the AWS provider. And it shows that without making any modifications to Delta, we were able to stay under our budget. And you can see kind of this U-shaped graph where at first it provisions a lot of resources from AWS, but then realizes that it's grossly overspending and will reach the budget too quickly. So Delta Plus does overcompensate a little bit, but then near the end of the workload, it does go more towards an equilibrium point. So current and future development, we're looking to extend Delta Plus further to the edge. I have a student who's working on extending to microcontrollers and kind of doing a federated learning system on very, very low power devices at the edge. We want to incorporate more of the auto scaling features that come with FuncX. Again, that's one of the reasons that we chose FuncX, because why would we want to provision instances if FuncX can do it for us? And then move to a model of a heuristic-free control framework, so that we don't have to, as users, as developers, worry about specifying specific rules for Delta to follow. And then we want to do some large tests. All of these have been fairly small with just at most a couple dozen endpoints, but we want to see how Delta scales to handle a lot of different endpoints. So with that, I will say thank you, and I will take any questions that you guys have.
Awesome. Thanks a lot, Matt. Any questions? Okay, I have a question. Do you think there's some capabilities of Delta that we could just lift out and actually plug into FunkX itself, like make them generally available?
Yeah, I think having that ability to do a automated, not necessarily selection of endpoints, but tracking of endpoints for individuals to be able to roughly put them in classes, to say not so much I want it to run on this specific workstation UUID that's so many digits long that I have to remember or write down someplace, but I just want this to run on a workstation. So kind of having classes of different resources, I think is definitely something that could be cool to implement into FunkX, just for easier tracking for people to hold on to.
Yeah, no, definitely. I think that would simplify a lot of people's lives. I see a question in chat from one T Sklizacek. Great talk, Matt. Where are you going to find 1,000 endpoints?
That's a great question. Yeah, so right now we have a Chameleon cloud allocation, and I know probably getting 1,000 endpoints on Chameleon would be way too much, but I think between AWS and Chameleon, as well as just the local resources that we have, we're not going to be able to get to thousands, but definitely in the 100 range. And I think once we have a solid technology demonstrator, that getting a larger, both a practical use case, I think that's a huge next step, where we're actually working on this for somebody, but then using that as a tech demonstrator to say, okay, we're ready for a larger allocation of some sort to test this on some of the largest systems. I think that's a little ways in the future, but definitely where we want to head.